Okay, so for this problem, we can see that the airplane is flying at a constant speed, 400 miles per hour. So if you look at the triangle that was shown here, let's call this one A, B, and C here, right?
Yeah.
And then A is gonna be and then we know that this flying horizontally. The airplane is flying horizontally at 400 miles per hour, so we can see that dA over dt is going to be equal to positive 400 mile per hour, because we can see that the plane is flying away from the radar, so the distance is increasing over time. That's why we have a positive rate.
All right.
B here is it's going to be a constant because the plane doesn't change the altitude. And then the distance from the radar to the airplane is denoted by c, and then they're asking for how fast it's changing, so we have to find dc over dt. See how fast is this changing, and let's call the data here. Let's call the angle here is data. We have here is a right triangle, so we can use the Pythagorean theorem for this triangle. So the addition of square of both sides is equal to the square of the hypotenuse. And then we can do the derivative of both sides. So I'm gonna have the color is not showing. So d dt of a square plus b square is equal to d dt of c square. So we do the derivative of, so we have the derivative of a square is going to be 2a dA dt because of chain rule, and derivative of b is 0 because b is a constant, equal to derivative of c square is 2c dc over dt because of chain rule. And then they want to know dc dt specifically when data is 30 degree. So we have to consider that special situation is that this one is 30 degree. So we have here is A, C, and B. Again, this one is a right triangle, so I can use sine or cosine. For this problem, I'm going to use cosine because I want to involve C and A and C, because that's the two variables. So cosine of 30 degree is going to be equal to A as a adjacent divided by C as a hypotenuse. And then we know that cosine of 30 degree is rad 3 over 2. So A will be equal to rad 3 over 2 times C. Does this one make sense?
Where'd you get rad 3 over 2 from?
Oh, because of the cosine of 30 degree.
Okay, and that's a special case.
Yeah.
Okay.
You can just use you can just plug it in the calculator. It's cosine of 30 degree is rad 3 over 2. And then so now I'm gonna substitute A everything we know in there. So we have A, so we have 2. So 2 of A, which is rad 3 over 2 of C times dA dt, which is 400 mile per hour plus 0 is equal to 2 times C dc over dt. So we multiply it out, so 2 and 2 over 2 is cancel. So we have here is 4. 400 rad 3 times c mile per hour is equal to 2c dc over dt. And remember that we are looking for dc over dt. So I'm going to have to divide it by 2c. You can see that c and c will be cancel out. And then 400 rad 3 over 2 is going to be 200 rad 3 mile per hour is equal to dc over dt. And 200 rad 3 feet over feet over second. Yeah, so we can see that it's 200 rad 3, although the unit is different. Could be typo. Anyway, they're also asking for the rate of change of the angles of elevation. So let's go back here for a second. We have, remember that we have cosine of theta is equal to A over C. So I'm gonna do the rate of change. I'm gonna do derivative right over here. So I'm gonna have d dt of cosine of theta is equal to d dt of A over C. Derivative of cosine is negative sine of theta times d theta over dt, because this is chain rule. A over C, this is quotient. So let's see derivative of the first. So dA dt times C minus dC dt times A over C square. Oh, it's too small. It is too hard to see. Does this one make sense?
Yeah.
The quotient rule over here.
Yeah, I get that part.
Okay. So again, we need to find d theta over dt because that's the rate of change of the angles of elevation. So I'm gonna divide it by negative of sine theta, divided by negative of sine theta. So d theta over dt is gonna be equal to dA dt times c minus dc dt times A over negative c squared sine of theta. They also want to know that specifically at 30 degree. So I'm gonna just plug in everything. dA dt is 400. C is, I'm gonna leave it as C minus dc dt we just found to be 200 rad 3 times A, and then we know that A is rad 3 over 2C. We found it right over here. And then divided by negative C squared of sine of 30 degree. So this one equal to so 400 so 400 C minus 200 rad 3 times rad 3 over 2 is going to give us 300 C over sine of 30 is negative 1 over 2 of C squared. Something is off here. I have to be able to cancel it out, but it didn't cancel out. Cosine of data is equal to A over C. So when we do derivative is equal to negative sine d data. Derivative C square. How do I get C? 400 miles and then 130. 30 degree. Can I do anything? It's 30 degree. 100, 200 C is equal to. Angle reach 30 degrees. So we have 30 degrees there. B is a constant. Oh, why do we do that? Yeah, forget about this part. I'm gonna do a different way.
Okay.
I'm gonna use sine of data is equal to B over C, because sine is opposite over hypotenuse, and opposite of data is B, and then hypotenuse is C. Let's see if it makes a difference. So I'm going to do derivative of both sides. So d dt of
I can't see
sine.
your screen.
Oh, sorry. So derivative of sine of data is equal to derivative of B over C. And then derivative of sine is cosine data times d data over dt. And then remember, oh, it doesn't work either. Either. Give me 1 second and give me 1 second. Let me ask. Oh, he's
Okay.
having